All right, in this video we're going to be looking at more composite functions and their derivatives. So on this first page we're going to be looking at information given to us in a table, and we'll have to evaluate some just composite functions and then sometimes derivatives of composite functions. So here are all the values of f, here are all the values of the derivative of f prime, g, and g prime. One of these examples is actually wrong. F of g of 3 would end up being f of 6, but 6 isn't on here, so if you want to feel extra fancy and cross off that first example, you're more than welcome to. But, wow. There you go. All right, so let's find g of f of 1. So in my table, I start working from the inside out. So f of 1 would be 3. So really this is g of 3. And then now I'm finding g of 3. So g of 3 is 6. So 6 would be your final answer. All right, in this problem, we have f of 4. So f of 4 is 2, so really then I'm finding f of 2, and f of 2 is 5. So your final answer would be 5 for that one. Now f prime of g of 1, we're still working from the inside out, so g of 1 would be 5, so then really I'm looking for f prime of 5, and so then I have to look in my f prime row now. F prime of 5 would be -4. Lovely. All right, and this one it says g prime of f of 4 squared. So I'll find f of 4 first. So f of 4 would be 2. So g prime of 2 squared, which would be g prime of 4. So then g prime of 4 would be 1. And then last but not least, we're finding g prime of f of 4, that whole thing squared. So in this one, g prime, well, like f of 4, if I look at my table again, is 2. And then I'm doing this whole thing squared. So then, oops, g prime of 2, g prime of 2 equals 4. So then I'm really doing 4 squared, which is 16. Okay, so that's just a little practice with tables and first derivatives and original functions. You'll have to do that in a Delta Math assignment. And then now we're going to get into some more of the chain rule. I told you there would be more examples. So they kind of broke this one down similarly to how we did in our last two videos. So finding the outer function, the derivative of the outer function, and then just the f prime of g of x part, and then multiply it by g prime of x. So we're just going to kind of fill out the table the same way that they have filled it out, and then we'll apply our chain rule together. So in this scenario, our outer function, which is f of x, so this one would just be the square root of x. That derivative is 1 over 2 square root of x. And then our g of x function would be 3x to the 5th plus 2x. This is our inner function. I don't know why that -4 is so far off on its own. There we go. And then the derivative of g would be 15x to the 4th plus 2. Lovely. And then, so now we're going to find f prime of g of x, because that's the derivative of the outside, keep your inside the same. That's the first part of our chain rule that we'll have to do. So basically it's saying I have f prime, and so I'm going to be plugging my entire g of x function in for this input here. So then really I get 1 over 2 times the square root, oops, of 3x to the 5th plus 2x minus 4. So derivative of the outside, keep your inside the same, and then to finish off my chain rule, we have to times by the derivative of the inside. So total here, we'll get this piece, right, my 1 over 2 square root of 3x to the 5th plus 2x minus 4 times the derivative of the inside, which is 15x to the 4th plus 2. If we just simplify it, the only thing I think we can do here to simplify is put that 15x to the 4th on top. So 15x to the 4th minus 2, or excuse me, plus 2, all over 2 square root of 3x to the 5th plus 2x minus 4. Awesome. All right, let's go ahead and do our next one. So in this next one, my outer function is an x to the 6th function. Its derivative is 6x to the 5th. My inner function is 3x minus 1. Its derivative is 3. And so then when I find derivative of the outside, keep my inside the same. I'm plugging all of this in for the inside piece here. So derivative of the outside, keep my inside the same. And then to finish off my chain rule, we'll have that. Oops, I want to do that. My final answer in black. So 6, 3x minus 1 to the 5th. Derivative of the outside, keep my inside the same, times the derivative of the inside, which is just 3. And so if we simplify that a little bit, you just get 18, 3x to the, or minus 1 to the 5th. All right, let's look at our third example. This one's kind of a secret derivative, or chain rule derivative, because you technically have a 2x cubed plus 1 inside of a 1 over x function, but we like to sometimes rewrite this to make it to make it easier for us to identify our inner and outer functions. Another way I could rewrite this whole thing is 2x cubed plus 1 all to the negative first power, right? That's what happens if I pulled it up in the numerator. It just would have a negative 1 power on it. So now it's kind of easier to see our outer and inner functions. Our outer function would be an x to the negative first power, and then its derivative would be negative 1 over x squared, because you would have, when you take this derivative, technically, we'll do a little side step here, it would be negative x to the negative 2, which gets me back here, right here. And so then that was my outer function. My inner function is 2x cubed plus 1, so its derivative is 6x squared. And then now derivative of my outside function, keep my inside function the same. So this was my original inside function. That's going to go in for my input here. I guess I should have been drawing little connectors in all of these as well, right? And so then I would end up with negative 1 over 2x cubed plus 1 squared. And then to finish off my chain rule, we have that piece. That's the derivative of the outside, keeping my inside the same. Then we have to multiply by the derivative of the inside, which is 6x squared. So negative 6x squared over 2x cubed plus 1 squared. Wonderful. Oops. All right, it looks like we got 2 more examples, and then we'll be done with this video, and you'll have plenty of chain rules to be looking at for examples. All right, outer function in this one is x to the 2/3. Oh, dang it. I always try to keep some sort of color coordination going on. And then that derivative, let's see, if I do my derivative for that piece, it would be 2/3 x to the negative 1/3. Which then would give me 2 over 3 cube root of x. All right, my inner function is 3 plus 6 square root of x, which, that derivative, 6 square root of x is the same thing as 6 to the 1/2, or 6 times x to the 1/2, so its derivative would be 6 over 2 square root of, let's do it, 6 over 2x to the negative 1/2, which then would give me 3 over square root of x. Okay. All right, so let's do this part. So now we do derivative of the outside. We keep our inside function the same. And then we'll finish off our chain rule. So the derivative of the outside, keep my inside function the same as 2 over 3 times the cube root of 3 plus 6 and the square root of x. So I don't like that. Root inside of a root. It's okay. Technically legal. And then, so we're going to finish off our chain rule. We would do 2 over 3 cube root of 3 plus 6 square root of x. So that's derivative of your outside. Keep your inside the same. Times, oops, and now we have to do the times the derivative of the inside, which is 3 over square root of x. Oof. And then to simplify this, not quite all the way, but to just kind of put it in any sort of semblance of terms, let's see, your 3's cancel. And I believe we have 2 over the square root of x times the cube root of 3 plus 6 times the square root of x. That's fine. We're just going to leave it like that. It's going to be great. Okay, let's go ahead and do our last example. Okay, so this is another one where it might be easier to rewrite it first to see how it's not the quotient rule. It is, in fact, the chain rule. So we could rewrite this as my 4 is still there, but then you can write 2x squared minus x minus 1 all to the negative third power. So now we have a more obvious chain rule problem approaching us instead of quotient rule. So for this one, our outside function is 4x to the negative third. Our derivative of that would be negative 12x to the negative fourth. Actually, let's do it this way. So then this way would be negative 12x to the negative fourth. But then to write it really in, so we can actually input things into it, would be negative 12 over x to the fourth, correct? Cool. And then my inner function is 2x squared minus x minus 1. So its derivative would be 4x minus 1. And then we do the derivative of the outside. We keep our inside function the same. And then we'll finish off our chain rule. So we get negative 12 over all that stuff, 2x squared minus x minus 1 to the fourth power. Derivative of the outside, keep my inside the same, times the derivative of the inside. So this piece is here first, right? Negative 12 over 2x squared minus x minus 1 to the fourth. Then we multiply that by the derivative of the inside, which is 4x minus 1. And then we could multiply this on top, making sure to distribute our negative 12 to each piece. So your final answer could be negative 48x plus 12 over 2x squared minus x minus 1 to the fourth power. Whew, there we go. So there are more examples of chain rule and kind of how to organize your thinking for it and to actually calculate those. Let me know if you have any questions. Other than that, you have some practice you can do.